This is the Raspberry Pi,
Okay.
which it just has a plastic cover on it that I made. I'm very proud of my plastic cover I made. I discovered that you can bend plexiglass with a heat gun. So you just take it outside and heat it up. You take it outside because the smoke detector goes off. You heat it up with a paint stripper, like a paint stripper, and you just bend it over the picnic table. So I made this elegant, and the original Pi had no mounting holes. So I had to make this little post arrangement that I hold in. The new one now has 2 mounting holes in it, but they were in such a hurry to get it out, and they were so cramped for board space that they didn't want to make holes. But so this is the Raspberry Pi running Linux. It's got an HDMI out that's going to drive the projector. It's got Ethernet to the network. It's got USB to the Launchpad, which is the MSP430, which is it's got 512 bytes of RAM and 16K of flash. So it's a pretty small processor, but it's more than enough to run this.
Sounds like the specs for my first computer.
It sounds like the not so good old days, doesn't it? So it does, and but it's also a 25-cent chip, so what you want. And the whole board with 2 of the chips. They include 2 chips, a USB cable, and a few other odds, and a couple of stickers for $4.30 with free shipping is a very attractive offer. This battery pack runs the servo, because that sucks a fair amount of juice. And if you try to power everything off the USB, USB is only good for about 1 amp, and the Pi draws about 700 milliamps, so you're right on the edge. So flaky stuff starts to happen. So I have my batteries from some kind of Christmas ornament I had, but that's powering only the servo. And then I have a USB hub, powered hub, because again, same power problem. I need to run a webcam and some other stuff, so I plug it into the hub, and then I plug the hub into the wall, and I got plenty of power to run the webcam and all that kind of stuff. So most of the wires hanging off this are power, and if I were to bundle them up more neatly, there is also a USB cable. This is really just supplying power. That's supplying power. This is the USB cable. This is the keyboard. I needed a keyboard because once I bring it up, I have to be able to start the demo. So I have it bring it up. You could make it, I suppose, completely autonomous, so it would come up, but I wouldn't know what the IP address was. So I can't completely automate it. And basically, I took these little boards that I got from Joann's. I mounted the boards on. I spent a lot of time at Michael's and Joann's. I mounted them on here just mostly for show, and I made them so they can unscrew, so I can take them loose and use them in another project. So my woodworking skills are okay, but my mechanical skills. This is the RC servo that Radio Shack sells these. Every hobby shop sells these. It runs on 5 volts, and essentially, you send it a string of pulses, and the more rapid the pulses are, the more it turns. It has an analog mechanism that keeps it pointed steadily at a given heading. And the software for something like Energia completely hides all the pulse width modulation, pulse repetition modulation stuff you have to do behind like one function call. You just say write, and you give it a number, which is a number of degrees, and it will go to that heading. It can swing 180 degrees. So my program just steps it. It takes 12 pictures, 15 degrees at a time. I just worked out empirically 15 degrees works pretty well for getting, you want some overlap in the images, but not too much overlap, because when you stitch them together, they have to have some overlap. But if they overlap completely, obviously it doesn't do what you want. So I divide 180 up into 12, comes out as 15, I think, was that wrong, and program it that way. So the Python script running on here sends the commands to the C program running on here to tell it to turn the servo. And then it also watches the webcam. There's a little web server running in here that's the webcam is feeding, and the Python script grabs frames from the webcam and saves them to the US. It kicks off the stitching program, which runs for about 7 minutes. Then it saves it to the USB stick. It could, as I say, at home, I actually push it out to Picasa, which is where those images got there. So I put the whole thing on this tripod so it'd be easier to see. And I have some hope if I could get the power straightened out, so I can run from a battery, then I can drag this out to outdoor location. You notice how my pictures are indoors? Because I need power. I would be much better to drag it outdoors and take maybe some pictures of Lake Pamela or this building. It'd be fun to do a series of pans up through this building because of the pictures you see. The distortion caused by flattening a cylindrical surface onto a flat surface actually looks very cool, because it looks like those pictures they take in architectural magazines when they come and they photograph your house, and it looks gigantic. It turns out it's the size of a closet, but because of the way the lines twist and vanish, it's sort of an optical illusion, and it makes everything look big. A picture of my cube, it looks gigantic. My cube is like this big. So it would be fun to stitch together like a whole lot of pictures too, and even if I had to manually just move this up, up, up every time I went around, that would work, as long as I was careful about how I moved it.